We're still going through the Learn You Node workshop. We're going to tackle a couple more exercises in this video. We're going to build a TCP time server, and we're also going to build an HTTP server that returns a file whenever it receives a request. Let's go get started. We are back to pick up work on the Learn You Node workshop. As usual, I'm here in my terminal. I'm at the Learn You Node project directory. Before we get started, I'm going to show you a pretty cool way to launch Visual Studio Code and open whatever project you want to open. We can actually do this here from the command line instead of having to first launch Visual Studio Code and then go through the GUI to open. I can just type code, space, and then a period. In the terminal, the period means the current directory. So what this will do is this is starting code and it's passing it the current directory. So it's basically telling it to open the current directory. And now it has opened it for us. If I bring up my sidebar in the Explorer, you can tell we've got the directory open. There are all our files. It's a pretty handy way to start code if you're already doing a lot of stuff in the terminal anyway. There is one caveat. If you're on Mac OS, you have to install these command line tools before that will work. And the way you do that is by pressing Command-Shift-P, which brings up your command palette, and then you just start typing shell. And this top one here for me, since it was recently used, is the one that I want to run, shell command install code command in path. That happens automatically if you're on Windows or Linux. Once you run that command, though, it installs code and you never have to do it again. Let's flip back over and see what our next exercise is. A time server. Create a file named timeserver.js. Write a TCP time server. Your server should listen to TCP connections on the port provided by the first argument to your program. For each connection, you must write the current date in 24-hour time in the format that they've given us here, followed by a new line character. Month, day, hour, and minutes must be 0 filled to 2 integers. And then here's an example of what they mean by that. After sending the string, close the connection. I want to look quickly at the hints. I've actually never done something quite like this before. For this exercise, we'll be creating a raw TCP server. There's no HTTP involved here, so we need to use the net module from Node Core, which has all the basic networking functions. The net module has a method named net.createServer that takes a function. The function that you need to pass is a connection listener that is called more than once. Every connection received by your server triggers another call to the listener. And here's the signature of the listener. Looks like create server is going to pass it a socket. Create server also returns an instance of your server, and we need to call the listen method on that server instance and pass in the port number to start listening on that port. And here's a brief example of what that looks like all put together. Let's flip over to code and get started writing this. I'll create my file, timeserver.js. We'll start by bringing in that core module I know we need. Get rid of the sidebar and this bottom console. Now we're calling our create server method. There's going to be a function passed in here that will get a socket. Not sure exactly what we're going to do in there yet. And then what was the method we need to call listen? And that's going to be passed in, so I can go ahead and get that out of process.argv. That's a good start. I could keep going through the hints, but instead I'm going to reference documentation. Let's look at this net module. What I'm specifically looking for is what the function that we're passing into create server should be, that connection listener. What do we need to do for that? Automatically set a listener for the connection event. They're calling their argument C instead of socket, and they're calling on that argument to listen to the end event. One thing I want to do, I realized I have used the old syntax for this instead of the arrow function. I want to flip that over. I sometimes default to that old function declaration syntax because I write a lot of JavaScript that runs directly in the browser, and I don't necessarily want to transpile it all the time. And that is something that every browser supports. But I do like to write using the ES6 syntax whenever I can. I'm going to leave this very open-ended for now. I'm not sure what event I want to listen to, and I'm not sure what I want to do once I hear that event. Let me see if I can find any documentation around what events I can expect. Okay, here is I think this is the class I'm getting back, because it looks like it's got the end event that I know is one of the events that you can listen for. Let me actually just look at that. Emitted when the other end of the socket sends a FIN packet, thus ending the readable side of the socket. Now let's go back to our project instructions. It doesn't say I'm looking to get anything in particular. I'm just listening to the connection on the port provided by the first argument, and then for each connection, I write the current date and 24-hour time. Based on that, I think end is probably the event I need to listen to. If I cared about what was coming through, I might listen for data so that I could get the data and look at it. Actually, now that I think about it, socket connections open, and then there's data that can be exchanged back and forth, and then they're closed. End ends the readable side of the socket. I think that means I can't send any data at that point. So maybe I actually need to listen for connect instead. Emitted when a socket connection is successfully established. Now let's see, what can I do with this socket after it is established? I'm going to look at the methods on the socket to see what sort of options I have. This one looks interesting. I can write sends data on the socket. I think that's what I need. Let's flip back over to code. Let's try this. I don't actually know if this is going to work, but I'm going to try listening for connect. Then if I have a connection, I'm going to write. Not sure yet exactly what I'm going to write. Let me flip back over to documentation for write. The first argument is the data. The second is the encoding, optionally, and the third is optionally the callback. The data I want to write is the date time in that format they specified. Let's see how I can actually get the date in this format. I'm just going to do a separate search for this. Date formatting, Node.js. Let's try that. Actually, this happens to be exactly what we want, I think. Let's see. Almost. We don't need the seconds, but otherwise, that format in that question is almost exactly what we need. Let me bump this text up so you can see it a little more easily. It looks like the most popular answer is to run the toIso string method on the date, which gives you back this format. Then you just cut out the things that you don't need. And I think that will work well enough for our purposes. I'm just going to grab this code and bring it over here. Before we write, I'm going to grab the date. What else is this replacing? Delete the dot and everything after. Okay, so that's this final dot. We still want to do that. We have one more thing we need to delete. We need to delete the seconds. And there are probably a few different ways we could do that. We could use a regular expression like these replacements do. But if you're watching this video, there's a good chance you don't know regular expressions. If you do, great. And you're welcome to do it that way. I'm going to assume that you might not, though. And that's not a super easy thing to teach quickly. So let's take another approach. What if we just wanted to cut off the last characters of a string? I'm just going to search for that and see what we come up with. This is the last character. We can use the substring. Ooh, also the slice syntax. Slice looks like a pretty good option. What's happening here is you are slicing something out of the existing string. The first argument is the index of the first character you want to include in the new string, and the second argument is the index of the second character. But if you'll notice, they've used a negative number here, and what that does is that counts from the end instead of counting from the beginning. So I could have put, we could have put 0, 10, and the new string would be everything between index 0 and 10, and honestly, I'm not sure if it's inclusive or not, but you can figure that out pretty easily. Or, in this case, we don't necessarily know, although it's the same number of characters every time, so we could do that, counting the positive index up to the point we want to stop. But I know we want to take 3 characters off the end, so instead of doing that, I could just do a -3 here. Let's try that. Slice. We want to start at the beginning, and we want to stop 3 characters from the end. I think if I save this, my formatter should format it. Yes, much nicer. I'm using the prettier extension for Visual Studio Code to do formatting, and I've got it set to format on save. So whenever I save a file, it automatically makes everything tidy for me. Now I have the date time I want to write out. I think maybe all I need to do is just write it. This should be everything. We're grabbing the port from the command line argument. We are creating the server. We're listening for a connection. When we get the connection, we are capturing the current date time in the format that we want, and then we're writing it back out to the socket. There may be something we're missing here. I'm not sure. Like I said, I've not done this before, but the easiest way to find out is going to be to run the validator. This validation is not completing, and I can just about bet I know why. The first thing I'm going to do to close out of this is I'm going to use Control-C, which sends an interrupt to the terminal, and whatever process is running will stop as soon as I hit Control-C. Let me flip back over to my code and I'll explain what I think is happening. We are creating the server and starting it listening. That kicks off sort of this ongoing process where the server is up and it's just listening. We don't currently have any way to end that. So what I think is happening is the verifier is kicking off that server and it's just listening forever. It may be doing what it's intended to do, but since it never ends, the verifier can't pick back up and give us the output of the verification. That means we need to figure out how to stop this server. And I think for that, we'll flip back over to the net documentation. Here on the server, we have a close method, stops the server from accepting new connections and keeps existing connections. The function is asynchronous. The server is finally closed when all connections are ended, and the server emits a close event. That has an optional callback that will be called once the close event occurs. And that callback will be called with an error as its only argument if the server was not open when we tried to close it. Now the question is, when do we want to close the server? And that's going to be after we write this data. I might just come back down here and write server.close. That might work. But before I lock that in, I want to see, is this write method asynchronous? If it is, and we kick it off, and then we immediately call server close, the data might not get written before we close. Let's take a look at that write method. Socket.write. It accepts a callback. That tells me this is asynchronous. In fact, if you look at the sentence here about the callback, the optional callback parameter will be executed when the data is finally written out, which may not be immediately. We don't want to close it until that data is written out, so we are going to pass the callback. And the only thing we need to do in the callback is close the server. Let's try that again. I'm just gonna, before I run this, I'm gonna do Command K to clear out my terminal buffer. This is still not working. I'm getting into the verifier and we're just hanging there. So something is up. We're not quite where we need to be still. I want to go back and look at these hints again. Maybe there's something else. This is what we've already done. Remember to use the port number supplied to you as the first command line argument. That we've taken care of. The socket object contains a lot of metadata regarding the connection, but it is also a node duplex stream in that it can be both read from and written to. For this exercise, we only need to write data and then close the socket. Use socket.write to write data to the socket. That we did. And socket.end to close the socket. Okay, that's where we made our mistake. We closed the server instead of the socket. So let's try socket.end here instead of server.close. And we'll flip back. It looks like that's basically what they have to tell us that we didn't already know. They're also talking about how to format the date, but I think we've got that figured out. We'll find out soon enough. Let's run the verifier again. Still not quite there. It's still just hanging after we start the verifier. Let me go look at those hints again. I think now we need to start doing a little bit of debugging on our own. One thing I noticed is that the hints did not mention anything about listening to this connect event. The description of the project said to listen for connections, so it makes sense that we would have a listener for the connect event, but maybe I'm wrong on that. I want to know if this event is ever actually firing. One way I could do that is inside the handler, I could log something out and just say connected, and then go back and run the verifier. That's never being logged out. That tells me we're probably not getting into this event at all. Another thing I could do is I could make sure this server is being created properly. To do that, I could just log out server created right here inside the create server callback. So as soon as that create server is done, it's going to call this function, and the first thing it should do is log out server created. Let's see if that ever gets logged. Here we go, server created. So that's happening. We know we're getting to here. We're never getting to here though. As an experiment, let's see if we just pull this stuff out and just put it directly here into the create server callback. Maybe that will work. I can't imagine that this write is going to succeed if we don't even know if there's a connection. I think we're going to have to get a connection first, but we're never getting a connection. So there's some sort of disconnect here. Let's see what this does. Control C to end that process. Verify again. Oh, this is the closest we've gotten. It's telling us two things. The first one is the time doesn't appear to be right. We are sending back 1702 and they're expecting 1002. Second is we're not sending back a new line, which is something they asked us to do. That we can fix pretty easily. I'm going to use a template string here. And we'll just append a new line to the end of that. Let's run that and just make sure that piece is good now. Yes, we have the new line. Now we just need to figure out why the time is not correct. I'm going to go back to the project description and the hints. The format appears to be correct. The one thing that's different about our implementation in comparison to what they've suggested in the hints is that we're using the toIsoString method. So maybe I should try to figure out exactly what that's doing. I'm just going to search for JavaScript date toIsoString. Here is the reference on MDN. The toIsoString method returns a string in simplified extended ISO format, which is always 24 or 27 characters long. The time zone is always 0 UTC offset. I'm willing to bet that is the problem. Not only is it getting it into the format I want, but it's also converting the time zone from my local time zone to UTC. It looks like the verifier is probably expecting it to be in my time zone. Let's look at these date methods and see exactly what they do. I know we need 0 padding on the day and the month, and the hour and the minute as well, I believe. Let's look. Yeah, month, day, hour, and minute must be 0 filled to 2 integers. Since I'm already in this date method documentation on MDN, I can just look up those others as well. Get full year, I know will be good. It's always going to get a 4-digit year. What else did they suggest? Get month. Let's see what that returns. That's going to return a single digit, which we'll have to pad. Date handling natively in JavaScript is really lacking. What we would have to do if we wanted to use these native methods is we'd have to get the full year, we'd have to get the month, and pad that out on the left side with a 0. We have to get the date, pad that out with a 0, get the hours, pad that with a 0, get the minutes, pad that with 0, smash it all together with the correct colons and spaces in all the right places. It's just kind of a mess. They have an alternative for us. If you want to be adventurous, use the strftime package from npm. It takes date formats just like the Unix date command. I'm going to check this out and see. Got the trailing parenthesis. Just looking at the documentation to see how difficult this is going to be to implement. Based on this usage, it looks like you can just pass it a format, and that will give you back the current date in that format, or you can pass it a format and a date to get that date back in your specified format. That's not too bad. There's another library that helps with date handling in JavaScript. And I want to just take a look at it and see what this implementation would look like in it. Now this one does a lot more than formatting. This does a lot of date manipulation. I'll bump this up so you can see. Here is a format helper. One thing I like about this as a solution is it looks like it's basically using the same formatting convention they have used in the project description. Capital M is a 2-digit padded month. 4 capital Ys is the 4-digit year. HH is 2-digit hour. MM is a 2-digit minute. Let's try to use this. I'm going to go to their getting started documentation and just see how you use this. It does work either in the browser or in Node. Okay, here's installation. We'll just grab this and install it using npm. Paste that into my terminal. Oh, actually, you know what? I don't think we have a package.json yet. No, that's not what I intended to do. No, I don't think we have one. Let's initialize one. npm init. This initializes this directory as an npm package. You might want to do that because you want to distribute a package through npm. In our case, though, we're doing it because we just want to be able to keep track of what external dependencies we have. Really, I don't care what all this metadata says that it's asking me for right now. The package name, I don't care what that is, because I'm not going to be distributing this. So I'm just going to return through everything. Whatever defaults it has are great. Is this okay? Sure, that's fine. Now, when I run this command that I've copied from the datefns website, the save option on the end of that command will actually work. It only works if you have a package.json file, and that npm init will create the package.json for you. Actually, before we run this, let's just take a quick look at the package.json. I'm going to use cat, which is a command line utility that just prints out the contents of some sort of text file. This is the contents of our package.json. It's exactly what we entered and confirmed earlier through npm init. Now, let's run this command. Added one package. It has installed that package for us. So if we use ls to list the directory contents, you'll notice we now have a node modules directory. And if I look into that and see what's in that directory, I have a datefns directory. That means that package is now installed. Also, while we're here, let's look again at the contents of the package.json. Now you see there is a brand new section called dependencies, and we have datefns listed there along with a version number. That is what the save option on our npm install did. It wrote that into our package.json. What that will do is, if we're ever sharing this project with another developer, maybe we're working on a team and we're trying to collaborate, they can pull this down onto their computer. They can run npm install inside the project directory. It will look at the package.json and go ahead and install any dependencies this project has. And since the dependency has a version number specified as well, it'll make sure it gets a version number that should be compatible with the version we wrote our code for. Let's flip back over to the documentation. And here's how we start using it. We need to import it. I don't need these. I actually just need the format helper. So I'm going to get rid of everything else. Let's flip back over, make sure I understand how to use this. I'm going to go scroll down to the common helpers, format. Let's see if they have any example code. Oh, actually, this is probably how we want to require it to remain consistent. I'll use const, and here's how we use it. Format, pass in the date, pass in the format. Pretty straightforward. I'm going to actually rename this now, because I think that's clearer. We don't need any of this formatting code we wrote before, so I'm deleting all of that. And I'm going to make a new variable, now formatted. We're calling this format method. We're passing in now. And let's flip back over and see. What format we want. I don't know if this will work, but I'm literally just going to copy and paste this format and see if it does work. Oh, and it needs to be a string. You have to pass in the format as a string, I believe. Format, type string, the string of tokens. Okay. Let's add our semicolon, and now what we're going to write is now formatted. Let's see how that works. Command K to clear out the buffer. That did not do anything because we generated an exception. And this is an issue with the format we just pasted in. Remember when I told you I'm not sure if that would work? It did not work. Use all lowercase y's instead of all uppercase y's. Fortunately, this is a fantastic error message. You hardly ever get anything this clear about how to fix your problem. Let's try this. And let's run the verifier again. Still no. More super helpful errors use lowercase d instead of uppercase. And I think month is going to be the same way. So I'm just going to change both of those. And let's see if that works. Not quite. What is happening here? They expected to get back 425. We gave them 2125. Oh, okay. you may notice, appears in this format twice because it's also used for the minutes. So we're printing out the year, the minutes, and then the date. This, I think, does need to be capital MM, and that's what I get for getting ahead of myself. Let's see how that works. This looks like a success. Yes. We have passed. We took the long way around, but we did it. Let's take a quick look at their solution. They have written a zero fill function just to add the left padded zeros on any single digit numbers. And you can see where they've done that in their now function when they return the year. And they've just manually hard-coded in the formatting they need with dashes and the spaces and the colon. They're running all the applicable segments through that zero fill function to make sure they get zeros if they need them. And this is interesting. Instead of calling the write method on the socket, they're just passing their value directly into end. That is something I did not realize we could do. Let's go look at that end documentation and just see why that works. Here's end. Half closes the socket, so it sends the fin packet. It's possible the server will still send some data. And then the first argument is the data. If data is specified, it is equivalent to calling socket.write followed by socket.end. Okay, interesting. We did not know that at the time. That would have been a way to simplify. And it would be easy to implement that. We'd just take this format string and pull it down here into end. And then we could pull end out of this write and just end it immediately. And then the write could go away. The write wouldn't be doing anything at that point. Another thing they've done is they have converted the port number to an actual number. It's getting passed in on the command line, so it's coming in as a string. That's what it is in process.argv. And they are using the number constructor to turn that into a JavaScript number. So instead of a string that says 3000 or whatever port number was passed in, it's actually the number 3000. It doesn't seem to be necessary because our solution is still working, but it's interesting to see that they made a point to do that. Maybe at some time in the past it didn't work to pass it in as a string. I'm not sure. Let's move on to the next exercise. An HTTP file server. Now we are getting into the stuff that you might actually do or actually touch as a web developer. You're probably not going to set up a time server, although you might, but you very well might be setting up an HTTP file server. Create a file named http-fileserver.js. Write an HTTP server that serves the same text file for each request it receives. Your server should listen on the port provided by the first argument to your program. You will be provided with the location of the file to serve as the second command line argument. you must use the fs.createReadStream method to stream the file contents to the response. That seems clear enough to me. I think I want to just dive into this one without really going into the hints. So I'll reopen my sidebar. You can click here or hit Command B, probably Control B on Windows. Just a quick note, this is a live directory listing. So you see that our node modules is here since we installed datefns earlier, and our package.json and packagelock.json. Let's create our file, http file server.js. All right. I did get a peek at the hints and saw that we're going to be using this HTTP package. We probably could have guessed that anyway, since we're setting up an HTTP server. So I'm sure we'll need this documentation at some point. We'll go ahead and get that ready. Let's go back over to the instructions. It's going to serve the same text file for each request. It should listen on the port provided by the first argument. Let's go ahead and set that up. And you know what? I'm going to go ahead and convert this to a number as well. Maybe they know something I don't. At the very least, if someone passes in something that's not a number, this constructor might flip out. So at least then they would know before we get to trying to pass it in as a port number to some other method. You'll be provided with the location of the file to serve as the second command line argument. That is going to be our file to serve. Now, I'm going to flip back to the HTTP documentation, and I'm just going to sort of browse through this. These are classes. We probably don't need to pay a lot of attention to those just yet. There is a server class. That might come in handy at some point. I am guessing there's going to be a method that will create a server, and it will return an object of that class. And here is that method, HTTP create server. Let's look at that. It takes two arguments. It takes an options object and then a request listener, which is a function. The options are incoming message, which specifies the incoming message class to be used. Server response, which specifies the server response class to be used. And then the insecure HTTP parser, which, when true, will accept invalid HTTP headers. I suspect we won't need any of those options, but we will need a request listener. And this returns an instance of HTTP server, which is the class I mentioned earlier. Let's scroll back up to the top and just look at that class. Here we go, HTTP server. Okay, cool. This is what I was looking for. I was a little surprised that create server didn't have an option to pass in the port that it was going to listen on, but that's because you have to call this listen method in order to get it to start listening. Starts the HTTP server listening for connections. This method is identical to server.listen from net.server. It looks as though this doesn't take any arguments, but I bet if we flip over here, yeah, this is what we used before, and we can pass in a port to it. That server is being returned out of this create server. That means we need to capture it in a variable. Then we can start it listening on the port that's been passed in. The last piece to this is to return the file. We need fs, which is one of the core Node modules that we've used in some of the previous exercises. There's create read stream. And I'm going to just pull up the file system documentation in another tab, file system fs. And let's find create read stream. Here we go. I just used Command F to start searching for that text on the page. Control F if you're on Windows. It takes one argument and an optional argument. The first argument is the path. That's going to be what we grabbed out of the arguments to the command line. And then options. I'm not sure we need to do anything with those yet. And this is going to return a read stream. Let's go ahead and pass in the file. Actually, I don't like that name anymore, file, because this is not actually a file. It is a file path. So I'm just going to change the name of that variable to make it clear when I read this later what I am dealing with. And I think we're going to need to capture this as well. We're going to call it file stream. Back to the documentation. Now I need to know, how can I use this server to send data? Let's go back up and look at the server class and see what all we can do. It has a request event. I think that's what we care about. Let me look at our instructions again. Serves the same text file for each request it receives. So yes, the request is what we care about. Let's look at that documentation. Okay, I'm pretty sure these bullets up here are the arguments that are going to be passed into the callback when we listen for this event. We're going to get a request and a response. Let's start by listening for that event. Oh, no, we need to listen to that with the server. Server.on request. And now we have our function that is receiving the request and the response. Flip back over to the documentation. We are building the response, so I want to know what this object looks like. This is the class that is coming back to us as this response argument. It is a http.server response object. So I want to see what this has. And I want some way to send something back. So that's kind of what I'm scanning for right now, a method that will let me send some data back. Okay, this looks like something, response.write. We pass it a chunk, an optional encoding, and a callback, also optional. Okay, I believe that is what we will need, is response.write. One thing I remember from a previous exercise, well, first, what we could do is we could put a listener on this file stream that listens for data. Then each time we get data, we could just use that write method on the response and just write it out to the response. That's one way to handle this. I remember, though, in a previous exercise, I don't think we need any of this date stuff again. We used a method called pipe that basically synced up a readable with a writable. And I wonder if there is a way we could leverage that here. We have a readable stream. We can then pipe that to a writable. Can we do it with HTTP though? Pipe readable stream to HTTP response. I could experiment and probably figure this out, but if someone is trying to do this, and I suspect they have tried to do this, this might be an easier way to find that out. This is how to pipe one readable stream into two writable streams. That's not really what we want. Let's try a different search. Node pipe readable to response.write. Here's some example code of how this person has implemented. Pipe writes it to the response for the client's view. This seems to suggest that the response itself is a writable. We can test that. Now what we want to do is filestream.pipe, and we'll pipe it to the response. Let's see if that works. I'm not 100% confident that it will. Oh, okay. I've really goofed here. I have saved this file inside my date functions directory. Let's fix that. I'm just going to drag it out to here. Yes, we want to move it. Okay, now I think we're in the right place. Yeah, looks good. I'm going to clear out the buffer. Oh, right. We're keeping everything open again. Let's close the sidebar. Let's search again for Node.js pipe. And I just want to see some documentation for that. It is a method of a readable stream. It looks like it takes the destination and it also takes some options. You can pass in an end key in your options object, and if that's set to true, then it should end the writer when the reader ends. I think that would be what we would want. So that would end the response, but that doesn't seem to be happening. Maybe we are misusing create server. It returns the server, but it will not, I don't think it will have returned by the time this callback is called. Let's take a look at that. I want to look at the create server documentation again. The request listener is a function which is automatically added to the request event. Okay, yeah, I've definitely misused this. So instead of manually listening for this request event, that's what this function does. So we can know that it will be passed the request and the response. And now I can do all of this stuff directly inside that and get rid of this request listener I was trying to write before, because this, in fact, is the request listener. Let's try that. Ah, that was the problem. Let's take a look at their solution. It's pretty much the same as ours. They don't capture these arguments into variables beforehand like we do. They create the read stream and then pipe it to the response the same way. They set up the server listener the same way. One thing they do that we didn't do is they write a header. What this does is when the response gets sent, first it has a 200 response code, which is a successful response. Also, it has a content type header that's set to text plain. Headers and status codes on responses tell the HTTP client some information about the response they're getting so they understand how to handle it. That wasn't part of the project specification for this exercise, but it is a standard of the HTTP protocol. So they have included that here in their solution. That's it for this one. We are getting closer and closer to the end, and we're just creeping up on some things that might actually be pretty practical. We've had to build up to that on the foundation of the exercises we've done up until now, but now we're starting to get into the real meat of it, the stuff that you might actually be paid to do someday. Feel free to work ahead, finish out those last 2 exercises, and then come back and watch the video to see how I solve them and maybe pick up a few things along the way. Thanks for watching. I'll see you next time.